Okay, so I tried previously to get a live stream going here talking about factoring and as it applies to the ACT math, which is coming up on Saturday. But I had some technical difficulties, so I had to kind of relaunch here. So maybe if you can let me know in the chat if you're able to hear what I'm saying and if you're able to see what I'm saying. If you can kind of let me know if everything's operating correctly here, and then we'll get right into this live stream. So again, if you guys could just kind of let me know, are you able to hear me okay? Are you able to see everything okay? How's the orientation of the screen here? Is everything okay? Can you kind of give me some feedback on that? So what I thought we could do today is we could take a look at just a review of factoring. Factoring is definitely something that they expect you to know on the ACT math section. So what I thought we could do is just kind of go through the different types of factoring that we should know by this point, in math. And then after that, what we'll do is we'll open it up to questions as it relates to ACT math type questions. So again, this is Mario with Mario's Math Tutoring. Okay, Raj says that everything's okay, no problem. Okay, so great. Thanks for letting me know about that. So we're going to jump right into this live stream. So the first thing that we want to know about factoring, okay, is this decision tree here that I put together for us. So you've probably seen something like this similar before in your math class. Maybe give me some feedback if this looks a little familiar to you. But basically what it is it's a decision tree. So what you do is you start off here at the top of the decision tree and you ask yourself, number one, is there a greatest common factor? Is there something that you can divide out of all the terms? And we're going to be looking at 10 examples going through all these different types. But just to kind of show you, the first step is the greatest common factor. And then after that, you ask yourself, okay, are there 2 terms, 3 terms, or 4 terms? Now remember, the terms are separated by plus or minus. So a term is like a group, and it's separated by that plus or minus sign. And then again, once you analyze how many terms there are, if there's 2 terms, you basically have to make a choice here. Is it a sum and difference of 2 cubes? Basically looking like this, a cubed plus b cubed, or a cubed minus b cubed, in which case you would factor it like this, okay? Or is it a difference of 2 squares, in which case it would look something like this, a squared minus b squared, and you would factor it as a sum and difference pattern. So we're going to look at all these different types today. Then the next type is when you have 3 terms. You either have a leading coefficient of 1, okay, so it starts off with a 1, or the leading coefficient is not 1, in which case you would then want to factor it using the trial and error method, or you could split the middle term and factor by grouping, okay? And generally the technique factoring by grouping, we reserve that for when you have 4 terms. We look at that as a possibility. So far, is everybody with me? Do you understand the basic idea behind this factoring decision tree? If you could let me know in the chat, I'd appreciate that. So yeah, so basically what we're doing, if you're just joining us here, we're going to be talking about factoring. Definitely an important concept to understand for the ACT math section. But then after that, we're going to open it up to questions. So, and then the last thing you want to do after you do this factoring is, it's just like when you're reducing fractions. You always want to ask yourself, can I reduce further? Or in this case, can I factor further, right? So let's get right into some examples, and we'll start to go through them. And I'll bring back this factoring decision tree here as it relates to these problems. Okay, so the first problem that we're going to do, and feel free to jump in if you know what we should do on this example. The first one we're going to work with is this one here, 6x squared minus 24x. Okay, so can anybody tell me what's the first step that you'd want to do when you're factoring this binomial? Now notice it's a binomial. You've got 2 terms, right? And the terms are separated by either minus or plus, so 2 groups. So what's the first step here if you're factoring this binomial? If you can let me know in the chat what the first thing that you would do is. Because remember, when you factor, the most important thing, first step is that greatest common factor, right? Then we're going to analyze whether there's 2 terms, 3 terms, or 4 terms, right? So what do you think? Okay, Raj says take it common outside the bracket. And so what is that greatest common factor? What can we divide out of both of these terms? What is that GCF? Can anybody tell me in the chat what that would be? So if you're just joining us now, we're talking about factoring. We're just doing a review of factoring, but then we're going to open it up to questions as it regards to the ACT math section. So Ethan says that it's 6, okay. Anybody else have a suggestion as to what we could do? Ethan, you're really close. Okay, 6 is part of the greatest common factor, but there's also something else that we can factor out besides that. Okay, Ethan is saying 6x and Raj is saying 6x. Okay, so yeah, exactly right. So when you look at both these terms here, notice they're both divisible by 6. That's the largest number that you can divide out of both 6 and 24. But then you can also factor out 1x. Okay, and Godot says 6x. Okay, that's exactly right. So what you're going to do is you're going to factor out that 6x. And what it's like doing, it's like factoring out or dividing out 6x out of both of these terms. So 6x squared divided by 6x is just going to give us 1x, right? And then 24x divided by 6x is going to give us 4. And you can see this minus sign, I'm just bringing that down in between those two terms. So the nice thing about factoring is that you know you have the correct answer because you can always just take that term on the outside, distribute it, remember the distributive property, distribute it into the parentheses. So 6x times 1x gives us 6x squared, and then 6x times negative 4 gives us negative 24x, and we know we got it. Now, if I can just bring back this decision tree here for us for a minute. So we factored out the greatest common factor, right? And we notice that there's two terms. So we have to ask ourselves, is it a sum or difference of two cubes, or is it a difference of two squares? So we're either looking at this one over here. Is it a sum and difference of two cubes, or is it a difference of two squares? So let's take a look. Well, it looks like x is not a perfect square. 4 is a perfect square, but this is not a difference of two squares. 4 is a perfect square, but x is not. So in this case, that's as far as we can go. And with factoring, again, you always want to see if you can take it further, but this is as far as we can take it at this point. Okay, Raj is saying x equals 1/6 or x equals 4. Now that's a good question, Raj. See, if this was an equation, like if it was equal to 0, and we were actually solving this equation, then what you would do is you would take each group, okay, so the groups are like the factors, each group, and you would make a mini equation. You would set each of those groups equal to 0, and then you would solve. So you'd divide both sides by 6, that's going to be 0, and then here you would add 4 to both sides, and that's going to be 4. So your two answers to this equation would be 0 or 4, but the original question was just asking us about, about factoring and factoring out that greatest common factor. Okay, so are you with me so far? Is everybody with me? Can you hear me okay? Is everything going smoothly? So maybe you can chime in on the chat. Are you guys getting ready for the ACT on Saturday? Is that what you're preparing for? Ethan says yeah. Okay, good. Have you guys taken the ACT? Okay, Godot says you're good. He's taking it as well. So are you guys, have you taken the ACT before? Like, how did you score the first time that you took the test? Were you, what kind of score did you get on the ACT math section the first time you took it, or the last time that you took it, I should say? Raj says the first answer was wrong. Okay, yeah, okay, gotcha. He can hear me. Okay, well, I'm just kind of curious. Okay, so let's go on to the next question. So the next question that we're going to do now is we're going to factor this one right here. Okay, so it's going to be 3x cubed. Okay, Robot Soto says, I haven't taken it, but it's still good to watch. Okay, that's good. Yeah, I'm glad you're interested. Godot says, took it in 7th grade, got a 21, taking it now in 10th grade. Okay, great. Okay, good. You should do a lot better this time around because you've definitely had a lot more math since then. So, okay, let's take a look at this one here now. So this one is a trinomial, so you've got 3 terms. And again, if we go to that decision tree, I always think about this. Eventually, you won't really need to refer to this sheet anymore. You'll just know what to do. So let's see here. So basically, the first thing you want to do is you want to analyze and ask yourself, is there a greatest common factor? Is there a GCF? Okay, so that's the first thing that we want to take a look at. So what do you think, you guys? Is there a GCF? Is there something that we can divide out of all 3 of these terms? Anything in common? Any thoughts? Anything we can divide out of each of these terms here? 3x cubed, 9x squared, and 15. Okay, Godot says 3. Ethan says 3 is the greatest common factor. Raj says 3x squared. Okay, well, Robot says divisible by 3. Yeah, so it looks like here, it looks like if you were to look at each of these terms, like individually or separately, it looks like the only thing that they have in common, the only thing that you can divide out of all the terms is 3. So let's go ahead and do that. We're going to divide all these by 3. And what we're left with is x cubed, okay, because these 3's are canceling. 9 divided by 3 gives us 3, okay, x squared, and 15 divided by 3 is 5. And notice I'm just putting the sign here, the minus sign in between those terms. Now what happens to the 3? Well, the 3 doesn't go away. It's still going to be there. It's going to be in front of the parentheses, so that if we were to distribute that 3, okay, back into the parentheses, we're going to get back that original trinomial. Okay, so are you with me so far? So first step is the greatest common factor. Now, you can see we've got a trinomial left over here, these 3 terms, but what we have to do is we have to ask ourselves now, can it be factored further? Well, it looks like, we've got 3 terms up here. The leading coefficient is 1. Okay, you can see there's a 1 right here in front of the x cubed. And so then what we want to do is we want to see if we can factor it into 2 binomials. Okay, and you can either do that by using a trial and error method, or you can try and split the middle term in factoring by grouping. But for this problem here, I'm just going to let you guys know just real quickly. We're going to get into some more challenging ones, but at this point, we're not going to be able to factor this further into 2 binomials. So really, this is as far as we can go right here, and that's completely factored. Okay, so you're with me so far. So now let's get into the next one, a little bit more challenging. Okay, we always want to take it up a notch, right? Make it a little bit more challenging. And again, you guys keep track of things that you want to ask me about regarding the ACT math section. I'm definitely, focusing on reviewing factoring here for you, just to kind of make sure you're up to speed on that. But we're going to open it up at some point here to talk about ACT math questions in general. So the next question I want to take a look at is the next factoring problem is this one right here, 9x squared minus 25. Okay, so remember the first step is what? Greatest common factor, right? So we want to see, is there something we can divide out of both of those terms, the 9x squared and the 25? Well, okay, it doesn't look like there's anything that we're going to be able to divide out there. So basically, we're going to go to the next step. So what's the next step? So if we look at our decision tree here, we have 2 terms, okay, and Raj is saying that we've got some perfect squares here, okay, and basically what we have here is we've got a difference of 2 squares. We have a squared minus b squared, and when you have that, you want to factor it in a sum and difference pattern. So you've got a plus b and a minus b, right? So you want to factor it as a sum and difference. So what we're going to do is we're going to go back and we're going to take the square root of both of these terms. So we have square root of 9x squared is 3x, right? Square root of 25 is 5, right? And one of these is going to be adding and one's going to be subtracting. And it doesn't matter if you make this first one minus and the second one plus, or vice versa, right? And again, the nice thing about factoring is you can always FOIL it out or multiply it out and see if you get back the original 9x squared minus 25. So we've got 15x and negative 15x. See how those cancel one another out? So that's giving you 0, and so you're really only left with the first terms, 3x times 3x, which gives you back the 9x squared, and positive 5 times negative 5, which gives you back the negative 25. So that's the nice thing about factoring. You can always multiply it back out and see if you factored it correctly. But again, remember with factoring, you always want to ask yourself, can you factor it further, right? Well, in this case, it looks like there's nothing else that we can do. We've got a binomial and a binomial, but this is not a sum of 2 cubes. It's not a difference of 2 cubes. It's not a difference of 2 squares. Same thing with this one. That's as far as we can go. So are you guys with me so far? So we've gone through about 3 of these. We've got about 7 more to go, and we're going to keep raising the level of difficulty. But if you guys have questions, go ahead and ask me now. And I'm going to just do something real quick with my with my phone, because I want to make sure that we don't get interrupted here real quick. So let me just see if I can do this while I'm talking to you. Let's see here. Let's see here. Let's see. I'm just going to put it on like that. Okay, guys, still with me? Can you hear everything okay? Okay, everything's good. All right, Godot says none so far, right? Okay, so let's go to the next. Let's go to the next example. So the next factoring example is going to be this one here, 8x cubed minus 27. All right. So when you look at that one, okay, Raj says I currently don't have a book to solve, else I can do it. Okay, yeah. So basically, let's see. We've got 8x cubed minus 27. So the the first step, again, is always to check for that greatest common factor. So what do you guys think? Is there a greatest common factor, something we can divide out of both of these terms? What do you think? Anything we can divide out of 8x cubed or 27? You guys figuring it out? So it doesn't look like there's a greatest common factor. It doesn't look like there's anything we can divide out of 8 or 27. This one has x cubed. This one doesn't have any x's. So there's not a greatest common factor. So if we go to our decision tree here again, okay, we notice that, okay, Raja's saying it looks like it's a difference of 2 cubes. Yeah, it looks like it's this one over here because you've got 2 terms, right? 2 terms. And you've got a perfect cube plus a perfect cube, or you have a perfect cube minus a perfect cube. In this case, we have a difference of 2 cubes. We're subtracting 1 cube and we're subtracting another cube. And so when we factor it, we're going to factor it in this pattern, a minus b, a squared plus ab plus b squared. Okay, so are you with me so far? So what we're going to do here is just recognize, and sometimes it's difficult. As you do these more and more, they'll start to jump out at you a little bit easier, but this is a perfect cube because 2x cubed, and 27 is a perfect cube because 3 cubed. And so in our formula, this is our a value and this is our b value. So again, let me just write down that formula here so we can see it. It's a cubed minus b cubed equals a minus b times a squared plus ab plus b squared. Now, some students remember this acronym. It's the SOAP acronym. It's same, opposite, always positive. So what I mean by that is, if you're subtracting here, it's going to be the same. You're subtracting here, and then it's going to be the opposite. If you're subtracting, then you're going to add. If you're adding, then you would subtract. And then the last term is always going to be positive, so that's going to be plus b squared. So that's where the SOAP acronym comes in. So in this particular problem, you can see that we're just going to substitute. We've got 2x, okay, that's our a value, minus 3, and then a squared, which is 2x squared, that's 4x squared, okay, plus ab, which is 2x times 3, that's 6x, plus b squared, which is 3 squared, that's 9, and then you've got it. Now, a lot of students, they'll always ask me this question. They'll say, well, can I factor this further? Well, as long as you factored out the greatest common factor at the very beginning, when you get down to this point where you're factoring, the difference of 2 cubes or the sum of 2 cubes, you won't be able to factor this trinomial any further. That's as far as you're going to be able to take it, and that'll be it right there. So, so basically, that's how you'd factor a difference of 2 cubes. So, what do you think? Any questions so far about this particular problem? Anything you want to ask me? Okay, Bobby's saying, how do I find the practice ACT math section that you made all the explanatory videos on? So that's a good question. So if you guys are preparing for the ACT math section, you can head over onto Mario's Math Tutoring YouTube channel, and here I'll actually show you right here on this sheet. So if you guys are interested, I'll just kind of mention, so you can go to my YouTube channel. I've got a lot of ACT practice tests that I worked out there if you're interested. I also have a huge ACT math review for sale, and I go through 65 concepts. It's got 3.5 hours of instructional video with examples, and you can check that out on my website at mariosmathtutoring.com or through the About page on my YouTube channel. But we're going to continue on with this factoring just to get you guys all reviewed up on factoring, but we're also going to open up to questions. So if you guys have ACT math questions, keep track of those. There's going to be an opportunity to ask those as we progress through this live stream, okay? So let's go back. So any questions about this one we just did with the difference of 2 cubes? Any questions about this one? Everyone okay with that one? Okay, so if we go to the next problem, okay, it's going to be this one right here. It's going to be 64y cubed plus 1. Okay, so what do you think? So if we follow that decision tree, the first step is what? Greatest common factor, right? So is there a greatest common factor? Okay, Ethan's asking, is this math also going to be on the SAT? Godot says no, and Raj says no, sir, let's move on. Okay, so so basically, the ACT and the SAT, the math sections, they're very similar. You're definitely going to want to understand factoring, and that's kind of why I'm going through that right now in this video. But definitely something important to understand. So for this one, what do you think? Is there a greatest common factor? Anything that we can factor out of both of these terms, both of these groups? Well, it doesn't look like there's anything in common between the 64y cubed and the plus 1. So then the next step is we want to ask ourselves, is this a difference of two squares? Is it a sum of two cubes? Or is it a difference of two cubes? Well, you can see that this is a perfect cube because 4y cubed, okay, right, the quantity cubed is 64y cubed. And then a lot of times students will overlook this, but 1 is actually a perfect cube because 1 times 1 times 1 is still going to be 1. So what we have here is we have a sum of two cubes. Very similar to that last problem that we were working with where it's a cubed minus b cubed. This is a cubed plus b cubed, and it's going to be a plus b times a squared minus ab plus b squared. Again, remember that SOAP acronym, same, opposite, always positive. So if you're adding, it's going to be the same. You're going to be adding, right? If it's subtracting, then this would be subtracting. It's the same. Then the next one is going to be the opposite. So if you're adding, this would be subtracting. If it's subtracting, this is going to be adding. And then the last one is always going to be positive. It's going to be, plus b squared. So in this case, you can see the 4y is our a, the b is our 1. Okay, Bobby's asking, is this stream only going to be on factoring? Okay, that's a good question. So the main thing we're focusing on here is just a review of factoring, but then we're going to open it up to questions, specific questions that you guys and gals have just regarding the ACT math section. So if you have ACT math questions, we're going to open it up and have an open question section where we can talk about other concepts or other problems that you guys are having that you want to talk about more. Okay, so yeah, so stay tuned, and we'll definitely get into that. Keep track of what you want to ask me, and we can go over those. But so for this problem, let's just keep going. Right now we're on number 5. We're going to do 5 more factoring problems after this. Okay, Raj is saying it's 16y squared minus 4y plus 1 times 4y plus 1. Well, let's see if he's right. So we've got 4y, that's our a, plus 1. A squared is 4y times 4y, which is 16y squared, minus 4y times 1, which is 4y, and then plus b squared. 1 squared is 1 times 1, which is 1. And that's as far as we can take it. We factored it completely, and we've got it. So that's exactly where you would factor that one, sum of two cubes. All right, so you guys with me so far? So we're going through these different types of factoring problems, and we're going to open it up for ACT math questions in a little bit. But let's go to the next one. So the next one, number 6, is 3x squared plus 13x minus 10. Okay, so what's the first step? First step is greatest common factor, right? So what do you guys and gals think? Does this have a greatest common factor? Is there something we can factor out of each one of these terms? Anything that's in common? Well, what do you think? Anything in common? Greatest common factor? Well, it doesn't look like there's anything we can divide out of 3x squared, 13x, and negative 10. So what we're going to do is we're going to proceed to the next step, okay? And so the next step is going to be asking ourselves, is there 2 terms, 3 terms, or 4 terms? Well, there's 3 terms, and we want to ask ourselves, is there a leading coefficient of 1? Well, in this case, if there's not a leading coefficient of 1, it's a 3, and so when it's not a leading coefficient of 1, you can either use the trial and error method, okay, or you can split the middle term and then proceed to factor by grouping, okay? That's when you have 4 terms. Okay, so we're going to use the splitting the middle term technique and factoring by grouping. And the way that we're going to do that is we're going to solve this riddle. Okay, so here's how it works. You take the a value, this 3, times the c value, this negative 10, and you just ask yourself, what 2 numbers multiply to negative 30, but those same 2 numbers have to add to positive 13. Okay, so you're with me so far? So I just took the 3 and I multiplied it by the negative 10, that's negative 30. So I said, what 2 numbers multiply to negative 30? Okay, and then, oh yeah, Godot says, have you ever heard of the slip and slide? You know, I actually have. I've seen students, do that technique, and teachers teach that technique. That's one that I'm not, that's not one that I typically use. I've seen it, and it definitely does work, but this is the method that I particularly like, so I'm going to show you guys this one. Raj is saying it's 15 and negative 2. Yeah, you're exactly right, because 15 times negative 2 is negative 30, and then 15 plus negative 2, I should say, equals positive 13. So then what you would do is you would split this middle term, okay, and it's going to be 15x and negative 2x, right? And then all you have to do is bring down the first term and bring down the last term. Okay, let me just section this off. And so then what you notice is you've got 4 terms here. You've got 1, 2, 3, 4 terms. And so then we have 4 terms. If I can just bring back that decision tree here for a moment, we can then see when you have 4 terms, you can factor by grouping. Okay, so that's what we're going to do now. We're going to basically take the first 2 terms, group those together, and then I'm going to just put a plus sign in here. I'm going to group the last terms. Okay, so now what we do is we look at each of these 2 groups and we factor out the greatest common factor. So what can we divide out of 3x squared and 15x? Any thoughts on that? Tana's here. Okay, welcome, Tana. So good. Yeah, what do you think? So 3x, that's exactly right. Good. And then you're just going to be left with x plus 5. And again, you can check your work. That's the nice thing about factoring. You can distribute that. And then what can you factor out of the this second group here? What's in common between the negative 2x and the negative 10? Well, what do you think? See, a lot of times what students will do in this particular, yeah, Tana's saying negative 2. Yeah, you're exactly right. It's negative 2. A lot of times students will factor out a positive 2, but if this starts with a negative number, I always like to factor out the negative number. And the way that you know you're on the right track is that after you factor out that quantity, you want to make sure that what's in the parentheses, see the x plus 5s here, you want to make sure that these quantities are the same. Okay, so now that we have an x plus 5 in common in this whole group, and this whole group, we're going to factor the x plus 5 out. Okay, and if we do that, we're left with 3x minus 2. And again, remember, you can always check your work. If you take this whole quantity, x plus 5, and you distribute it to the 3x, you get back the first group. And if you take the x plus 5, you distribute it to the negative 2, you get the second group. And so now you've got it completely factored. So any questions about the splitting the middle term and factoring by grouping like we did in question number 6 here? Any questions about that? And I just want to mention, if you guys and gals, if you know of other friends or family that are preparing to take the ACT, coming up here, and you want to let them know about this live stream, we're going to be on here for, we're going to try to keep it under an hour, but if you wanted to, let others know about it, that'd be great. The more the merrier, right? We can always get some more input and learn from each other, right? So yeah, so that's number 6. So basically splitting the middle term and factoring by grouping. But let's go on to the next question now. Okay, we're going to go on to number 7 and see if you can factor this one. So number 7, we've got 12x cubed plus 8x squared minus 9x minus 6. Okay, so what do you think here? What do you notice about this one? First step is greatest common factor. Is there a quantity that we can divide out of all 4 of these terms? Remember, the terms are separated by plus or minus, right? So we've got 4 groups, 4 terms. Is there a GCF we can factor out? What do you guys think? Well, there's not a greatest common factor, but you can see that there's 4 terms. Okay, and Tana's saying you can do factoring by grouping. Yep. Okay, that's right. Yep, exactly right. So when you have 4 terms, you can group the first 2, and you can group the last 2, and all you have to do is put a plus sign in between those 2 groups, and you can proceed from there. So the next step is to factor out the greatest common factor. In this case, it looks like we can factor out a 4x squared, which is going to leave us with 3x plus 2. And then here we can factor out a negative 3. Again, remember we want to factor out that negative if you can. Okay, which is going to leave us with 3x plus 2. And you're on the right track because you've got a 3x plus 2 in common. If we factor that out, we're going to be left with 4x squared minus 3. And again, if you have any question as to whether you've done it right, just go ahead and do the distributive property twice, or you can FOIL, or you can use any of those techniques that you use for expanding out, a binomial times a binomial. But again, remember with factoring, you always want to ask yourself, can we factor this further, right? Well, here you can see 4x squared is a perfect square. 3 is not a perfect square. If this was a perfect square, then we could factor this as a difference of 2 squares. But in this case, it's not a difference of 2 squares. That's as far as we can go, and we've got it. Okay, so are any questions about the factoring by grouping? Anything you want to ask me more about that one? You guys okay with that? Okay, so let's go to number 8 now. Okay, so number 8 is 5x squared. We're going to do 10 of these, okay? So let's see, 5x squared minus 125. And so, again, remember the first step is the greatest common factor method. So what do you guys think? Is there a greatest common factor for this one? Is there something we can divide out of both terms, both groups? What do you think? Anything in common? What do you think? Is there a greatest common factor? Can you let me know in the chat, or let us let everyone else know too? Are you guys thinking about, okay, Tana's saying 5x, Godot's saying 5, Raja's saying 5. Okay, good. Yeah, Tina changed her answer to 5. Yeah, that's exactly right. So it's going to just be 5, okay, because there's not a variable in this group, just an x squared in this first group. So they only have a 5 in common. And so if you divide both these groups by 5, you can see you can reduce this down to x squared minus 25. But don't forget about that 5. You want to put it in front of the parentheses. This way, if you distribute that 5, you're going to get back the original. Okay, now can we factor it further? Okay, Tana's saying do differences of squares. Okay, yeah, like a difference of 2 squares. Okay, is she right? What do you guys think? Is she on the right track? Difference of 2 squares? Well, yeah, she is right, because x squared is a perfect square, 25 is a perfect square, 5 times 5, and then one of these is plus and one of these is minus, and you just want to bring down, don't forget to bring down that 5. So if you were to multiply all this together, you're going to get back the original 5x squared minus 125. Now remember, if this was an equation, like if this was equal to 0, then we would take it one step further and we would set each factor, each group equal to 0 and solve. But for right now, we're just factoring. Okay, so everyone with me so far? We've got 2 more factoring problems to go. Okay, and then we're going to start talking about some other topics. But any questions about that? So basically with factoring, you just want to keep factoring until you can't factor any further. Okay, so let's go to number 9 and 10, and then we'll move on to some other things. Okay, and again, the more that you guys can kind of give me some input as to what you want to talk about, I think the more that we'll all get out of this. As far as helping each other for the ACT math section. So let's see. So for this one, what do you think? Any ideas? What would you do first on this one? You've got a trinomial, right? 1, 2, 3 terms, and first step, remember, in factoring, it's always that greatest common factor if you can. Is there a greatest common factor? What do you guys think? Okay, Godot says factor out 3. What do you think? Is he right? It's 3. Take out a 3, Bobby says. Yeah, okay, good. Yeah, so that's exactly right. So we want to factor out the 3. And if we do that, we're left with x squared minus 3x minus 10. Okay, so now, again, with factoring, you always want to ask yourself, can you factor further? So what do you guys and gals think? Can we factor this any further? Well, we've got a trinomial, 1, 2, 3 terms. The leading coefficient's 1. Now, when the leading coefficient's 1, it's pretty easy to factor, right? So you guys probably remember this from your math class. You just have to ask yourself, what 2 numbers multiply to the last term, negative 10, but they add to this middle coefficient, negative 3. Okay, so Tana's saying negative 5 and positive 2. Is she right? Has to multiply to the last term, negative 10, but add to negative 3. Okay, Bobby's saying 3 times x minus 5 times x plus 2. Is he right? Okay, all right. Well, let's take a look. So you guys are right. Negative 5 and positive 2, that's going to give you the negative 10, right? And then what you're checking is the inside, negative 5x, and the outside, positive 2x, adds up to the middle term, negative 3x, right? And again, don't forget that coefficient that we factored out at the very beginning, that greatest common factor. You want to put that in front. And then again, you just take a quick look, see if you can factor it any further. In this case, we really can't, and so you're done. So let's go to the last factoring question here, okay, number 10. Is this helpful? Are you guys kind of refreshing, or was this kind of a little bit too easy? I know a lot of the people that tune into these live streams and into some of my video lessons on my Mario's Math Tutoring YouTube channel, they're really sharp at math already. They just want to kind of review some things. But I know some students, they're still learning. So let's take a look at this one here. So we've got 4 terms, right? 1, 2, 3, 4 terms. And what do you think? What's the first thing we should do? Okay, Godot says too easy to be honest. Okay, Tana says factor by grouping. Yeah, so there's not a greatest common factor. There's not something that we can take out of all the terms. And we can see that there's 1, 2, 3, 4 terms. So yeah, you're absolutely right. We want to factor by grouping. We want to group the first 2 terms, group the last 2 terms, and just realize that these are added together. Okay. So what can we factor out of these first two terms, this first group here? What's the greatest common factor? Anything we can divide out of x cubed and x squared? What do you think is the greatest common factor? Okay, Tina's saying x squared, Raj is saying x squared. Yeah, you're right, it's x squared. And what's going to be left inside the parentheses? What's going to be left inside here? So we're basically dividing these terms both by x squared. So sometimes students get a little bit confused by this. Anything divided by itself is 1, right? And then x cubed divided by x squared is just going to be x. And again, the nice thing, okay, Tina, you're right, x plus 1. Okay, Raj, you're right, 1 plus x. When you distribute, you can always check your work. See, that gives you back x cubed, that gives you back the x squared, and you can just verify. What about in this second group? What can we factor out here? Anything in common? Anything greatest common factor? What do you guys think? Okay, Jessica Randeep. Okay, thanks for joining us. You're saying -4. Yeah, Tina, -4. Yeah, you're absolutely right. So if you factor out a -4, we're also left with x plus 1, okay, which is good because you can see there's an x plus 1 in this group and x plus 1 in this group. So if we factor that out like a greatest common factor, we're going to be left with x squared minus 4, right? Okay, now the question with factoring is, just like when you reduce fractions, you want to say, can I reduce it further? Can I break this down further? What do you think? Is there anything we can do with the x plus 1 or the x squared minus 4? What do you guys think? Well, okay, Tana's saying differences of square. Okay, yeah, that's exactly right. You've got a perfect square, which is x times x. 4 is a perfect square, 2 times 2. Okay, Raj says x minus 2, x plus 2, and x plus 1. Yeah, that's exactly right, because this is going to be minus, this is going to be plus, or vice versa. Okay, so it's a sum and difference pattern. And then you just bring down the x plus 1, and you've got it. So any questions about the factoring by grouping method, this technique when you have 4 terms? See, the key is, to group the terms. Okay, and I'll show you some mistakes that students sometimes make, like, and I don't think you guys would make this mistake, but just to show you, write it out again real quick. Here's a mistake that some students will make. See if you can see what I'm doing wrong right here. They'll go like this, and they'll go like this. So what did I do wrong there? Can you see what I did wrong? Can you guys let me know in the chat? What do you think? That's a common mistake, because students are thinking, okay, yeah, I'm factoring by grouping, so I'm going to group those first two. Okay, Tina says forgetting the negative. Yeah. See, the thing about subtraction is, and then see, here's where they make another mistake. The students will go like this. They'll say, oh, this is supposed to be plus, right? So I'll distribute this negative like this. So I just made another mistake. What I do wrong there? Anybody catch what I did wrong there? I distributed that negative in there. What was wrong with that? Uh-oh, did I stump you guys? Okay, so basically it was like this, x cubed plus x squared minus 4x minus 4, right? See, the thing is, when you subtract, subtraction is like adding the opposite, right? So then what you can do is you can just, at that point, you can say, well, I'm going to group these two, and I'm going to group these two, right? So then you can factor out that -4 as a greatest common factor. Okay, so what do you guys and gals think? Any questions about factoring at all? Anything you want to talk more about in regards to factoring? So what do you think? Any questions about that? Anything you want to ask me more about factoring? Otherwise, what we're going to do, my plan was, because we've got the ACT coming up here on Saturday for a lot of students, was to talk more about the ACT math section, So I think I mentioned to everyone before at the beginning of this live stream, but I'll just mention it again. If you're studying for the ACT, we've got a few different resources here. One, you can go to, Mario's Math Tutoring YouTube channel. I've got a lot of ACT problems worked out there. There's some ACT playlists you can check out. Another option, if you're interested, I have a huge ACT math review video course for sale. It goes through 65 concepts. It has 3.5 hours of video. And I go through some teaching sections, and there's a lot of different examples that you can practice, and then we can go through in the video to see, if you're on track with understanding those concepts. So a lot of students are finding this really beneficial. Definitely something you might want to take a look at. So you can find that through my website, mariosmathtutoring.com, or from my YouTube About page on mariosmathtutoring.com. But at this point, I think what I'd like to do is just kind of, open it up to questions regarding the ACT, math section. Okay, English and science, we're not going to talk about those. I just focus on the math part. Okay, so Tana says graphing inequalities. Okay, great, good question. Okay, so I'm just writing these down just off to the side so I can kind of look at what we want to do. Okay, what else? What else you want? Trig problems. Okay, Jessica Rondeep is saying trig problems. Okay, that's a good question. All right. What else? Having trouble with this question. Given g of x equals x plus 1 divided by x squared, which of the following expressions is equal to g of x minus... Okay, that's an interesting question. Okay, so let me see. Any other ones? I'm just kind of making a list, see if there's something in common that we all want to talk about together. So what do you think? I've got a couple, 2, 3 ideas down here so far. Anything else you want to talk about? Circles? Okay, Tana's saying about circles. Okay, that's a good question. What else? What else would you guys like to talk about? Radius of circles. Okay, yeah. What else? Any other ones? Okay, well you guys keep track of what you want to talk about. Let's start off by talking about graphing inequalities. Okay, so geometry, Bobby's saying, differentiation. Well, we won't talk about differentiation because that's not tested on the ACT math section, but okay, so let's start off by talking about graphing inequalities. So I'm going to show you 2 different examples here. Actually, I'm going to combine them into one problem. We're going to graph y is less than negative 2x plus 3, and we're going to graph this one here, x minus 2y is greater than or equal to 10. All right, so see if you guys can help me out with this problem. So I'm going to just draw a little x and y coordinate plane here for us, like so, x and y. Now you've got a couple different options when you graph inequalities. Okay, one option is you can use if you're familiar with the slope-intercept form, the y equals mx plus b form, the m is the slope or the rate, and the b is the y-intercept or the initial condition. And if you look at, okay, Raj is taking off. Okay, all right, Raj, thanks for joining us. We'll see you next time. So basically, when you look at this first inequality, you can see that it's in that y equals mx plus b form, just like what I have written over here. The b value, the y-intercept, is 3. Okay, so 1, 2, 3. So it's crossing right there at y equals 3. And then the slope, okay, the m value, the number in front of the x, is negative 2. You can think of that as negative 2 over 1. So from this point, from this y-intercept, I'm going to go down 2. I'm going to go right 1. And you can repeat that process, down 2, right 1, and so on. Because this is a less than but not equal to, it's going to be a dashed or dotted line, like so, right? And then, now here's where you have a couple options. You can either pick a test point, like 0, 0. You put 0 in for y and 0 in for x, and you simplify and you say, is 0 less than 3? So if I simplify this, is 0 less than 3? That's where this point is, the origin. Okay, Godot's taking off. Okay, we'll see you. Okay, thanks for joining us. I appreciate it. So, yes, 0 is less than 3. So that means this is the true side of the line. This is the side of the line we want to shade right here, right? The other way to do it is when you get the y by itself, okay, the y controls what? Y controls the vertical, the up and down direction, right? So if the y values are less than negative 2x plus 3, less than, it means below. So what we're doing is we're shading down. If you pick a point on this line and you shade down, that's going to be below or less than, right? Okay. Okay, so then the next step, okay, is to basically, once you identify what side of the line, you shade that side of the line. But what we're doing here is we're actually working with a system of inequalities. We've got 2 of them, okay, and we want to graph them in the same coordinate plane. We want to find out the overlapping region, right? Okay, so for this one, we've got x minus 2y is greater than or equal to 10. What do you guys think? So in this particular problem, what I'm going to do is I'm going to use the intercept method. So I'm just showing you 2 different techniques for the same problem here. But what I'm going to do is I'm going to make a table. I'm going to set x to 0 and I'm going to set y to 0. Okay, so if I set x to 0, 0 is just going to be 0, so I'm covering that up. Divide both sides by negative 2, y comes out to negative 5. Okay, so what that tells us is it's going to cross the y-axis right down here at negative 5, right? Whereas if I set y to 0, okay, so y to 0, negative 2 times 0 is 0, that's why I'm covering that up. You can see that x is equal to 10, right? So that means it's going to cross over here at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, approximately right there, right? And then it's greater than or equal to 10. That means this is a solid line. Okay, Tana's asking, why would you not rearrange that inequality? Oh, that's a really good question. This is just a different way of doing it, Tana. I'm going to show you how the two are equivalent. You can do whichever way you're most comfortable with. Sometimes, though, when the variables are on the left side of the inequality and the numbers on the right, it's quicker just to do this technique of setting x to 0 and then setting y to 0 and solving for the intercepts. But I'll show you the other way as well. So this one we decided was a solid line, right? Because it was equal to 10, right? That's the key. But now here's where students sometimes go a little bit off track. Okay, they see the greater than or equal to sign, and they automatically say, well, greater than, I'm going to shade above this line, right? But why is that wrong? Can anybody tell me why that's wrong? Why wouldn't you just want to just like shade above? I mean, isn't that a greater than sign? Wouldn't we shade above this line? What's wrong with that? Well, what's wrong with that is if we do a test point, like let's say we take that point 0, 0, the origin again, if we put that in, we get 0 minus 2 times 0 is 0. 0 is not greater than or equal to 10. Yeah, Jessica Randip is saying the test points. Yeah, it doesn't work out. See, 0 is not greater than or equal to 10. It's actually less than or equal to 10. So where this point is, the origin, that's false. That means this is the false side of the plane. This is not going to be true. We have to shade the other side of the plane, like so. Now when you look at it, you say, okay, it looks like these two regions are overlapping right here. So I'm just going to go back and shade that in a little bit darker. This is going to be our solution set right here. Okay, so you're with me? But to Tana's point, why wouldn't you rearrange it? Well, you certainly can. I mean, that's another option. So let's go back to this over here and let's just rearrange this inequality. So you could say negative 2y is greater than or equal to negative x plus 10. I'm just subtracting the x from both sides. I'm going to divide everything by negative 2, which that's going to give us a positive y. This is going to be 1/2 x minus 5. But what happens to the inequality sign when you multiply or divide by a negative? Okay, Tana says flip the sign. Yeah, you're exactly right. It's going to flip. Instead of greater than, it's going to become less than, which then makes sense because remember the y controls the vertical direction up and down. So if the y is less than, that means we're shading below the line, which is exactly what we did. So you kind of have a couple of options. Like your first option is, to get that y value by itself, right? Put it into this slope-intercept form, this y equals mx plus b form. Then if the y values are less than, like this first line was right here, then you're shading straight down. Remember, because the y controls up and down, less than is below. But if it was greater than, like we had over, actually we didn't have a greater than one. See, originally this one looked like it was greater than, but when we solved for y, the inequality sign actually flipped and it was less than. Again, we were shading below. And then with a system of inequalities, you find out where they overlap. But again, sometimes in the interest of time, I mean, ACT, SAT, time is an issue. Sometimes you might want to just use this technique of finding the x and y intercepts by setting the opposite variable equal to 0, plugging those test points in, and then use like a test point like the origin 0, 0 to see if that's the true side of the plane that you want to shade, or if that's false, you want to shade the other side, right? So any more questions about inequalities or graphing inequalities or solving inequalities? The main thing, in my opinion, okay, my personal opinion from what I've seen, is that okay, and Mr. Nate Dog is asking, do you flip the sign if you're dividing by a negative? That's the key. If you're exactly right. If you're multiplying or dividing by a negative, the sign changes direction or flips. But if you're adding or subtracting a negative number, that doesn't affect it. Only multiplying or dividing both sides of the inequality, that's what's going to change it. And that's what they really are testing you on. They want to make sure you understand that concept. So I think you guys got it at this point. What do you think? Any more questions about this problem or graphing inequalities in general? Or here, if you're just joining us, we're talking about ACT math. I know a lot of students are taking the test on Saturday, so we're just kind of preparing for that. So, okay, Bobby's asking, can you explain graphing trig graphs? Okay, so Bobby, when you say trig graphs, you mean like graphing sine and cosine graphs? Is that what you're talking about? Like how to graph like y equals sine x and y equals cosine x and all that? Yeah, okay, let's take a look at that. Is everyone okay with that? We talk about trig graphs a little bit. All right, so if you're just joining us, we're just doing some ACT math review. We're just doing a little live stream here with Mario's Math Tutoring. That's my YouTube channel's name. And if you're interested, again, like I was talking about earlier, you guys can check out the huge ACT math review, the 65 concepts and 3.5 hours of video. I've just put this together fairly recently, and it's got a lot of good information on there, a lot of practice, a lot more than we're going to probably be able to cover in these live streams. So that's something definitely worth purchasing if you're interested. Definitely check that out on my YouTube channel About page or on my website, mariosmathtutoring.com. So I would definitely highly recommend that if you're interested. Check that out. But let's go and talk a little bit about the trig, graphing the trig functions. Okay, so let's do that. So here's the thing. There are a couple of things we're going to look at in this problem. We're going to try to do a couple problems in one, if you will. So I'm going to graph y equals 2 sine 1/2 x. Okay, so can anybody tell me what does the 2 do to the graph and what does the 1/2 do to the graph? Can anybody tell me what does the 2 do to the graph and what does the 1/2 do to the graph? And I also wanted to mention, if you haven't subscribed to the my YouTube channel yet and you're interested in doing so, yeah, definitely subscribe to the channel, and you can also check out a lot of the videos. I think I have over 400 some videos on there now, just going over all different concepts that are covered on ACT as well as in your math classes. It's strictly a math tutoring YouTube channel, so check that out. But let's see, Tana's saying half is a horizontal expansion of 2, and Lexi is saying the half makes it longer. Basically, you're talking about horizontally. Yeah. Okay, so let's take a look. Well, you guys are right on. Okay, so the thing is, this number right in front of the sign, to the left of the sign, okay, this is our amplitude. This is our vertical stretch. Whereas this number here that's grouped with the x is going to affect the x direction, the horizontal direction, but it's actually going to have the opposite effect on the graph. Okay, do you know what I mean? So it looks like you're dividing by 2. It's actually going to multiply the x values by 2. Now, before I graph this, can anybody tell me what the, okay, let's see, 0.5 says makes the FP 4 pi, I believe. Yeah, so that's interesting. So I was going to ask you, so what's the period of the parent function? So what is the period of the parent function for sine and cosine? Like, how long does it take for it to complete one cycle before it repeats? Can anybody tell me about that? Well, normally the period for sine and cosine is 2 pi, right? But because this 1/2, it has the opposite effect. It's actually, it looks like you're dividing x's by 2. I mean, this looks like x over 2, right? It actually has the opposite effect. It multiplies the x values by 2, which means that our period is going to be 4 pi now, right? And then the amplitude is normally 1, but because we said this number in front of the sine or cosine to the left actually affects the vertical stretch or compress. If it's greater than 1, it's a stretch. If it's less than 1, like between 0 and 1, it's a compress. And if it's negative, can anybody tell me what happens to the graph when it's a negative? What do you guys think when it's negative? This a value is, this coefficient is negative. Yeah, Tina says reflection. Yeah, it's a reflection over the x-axis. It makes all the, yeah, Lexi's right, it flips over the x-axis. It makes the y values the opposite, right? Okay, good. So what we're going to do here is we're going to graph the sine. Okay, so I'm just going to graph the basic sine graph like this. The period, it completes one cycle in 4 pi, like that, and then, of course, it starts to repeat like that. And then what I'm going to do is I'm going to divide it up into 4 pieces, right? So I'm going to divide it in half, that's 2 pi. I'm going to divide that in half again, that's 1 pi. And so you can see our scale is 1 pi, 2 pi, 3 pi, 4 pi. And then the amplitude, those are the height, that's the height of the wave, right? So it reaches a height of 2, okay, and down here to negative 2. Okay, so what do you think? So basically when you graph the sine graph, the sine graph, unless it's been shifted, it starts at the midline, okay, right here at the x-axis, and it goes up, back to 0, back to the minimum, back to 0. So some students will remember like 0 max, 0 min, 0. Okay, but if you're graphing a cosine graph, it actually starts at the maximum, right? Starts up here at the max, 0, min, 0, max, and then it repeats like that. Okay, they're basically the same type of graph. They have that S-shaped graph, right? Okay, Lexi says, I see that it's a lot easier than I thought it was. Yeah, it is a lot easier. The main thing is to know the basic graph. And if you're wondering, like, well, where do these graphs actually come from? What you do is, you look at your basic unit circle. I don't know if you guys have studied the unit circle yet. I imagine a lot of you have. But if you look at these key points on the unit circle, okay, these cardinal points as they call them, right, like northeast, southwest. See, when you're graphing the cosine graph, use the x-coordinates. See 1, 0, -1, 0, and back to 1. So if you kind of look at my graph here, when I'm at 0 degrees, I'm at +1. But then when I'm at 90 degrees, see right here at pi over 2, I'm back to 0, right? And then when I'm at 180 degrees, okay, I'm at -1, so that's this point right here, -1. And then when I go up to 270, I'm back to 0. See how the x-coordinate is 0. And then I'm back to +1, and that's my max. And then you can see it starts over because we're actually going in a circle, right? It's like a circular graph here. It's just that we're graphing it here in 2 dimensions instead of in the circular fashion. So, okay, Godot says, how do you find the period of the function? Okay, well that's a good question. Now, if you want to, it's a very good question. So if you want a formula, okay, and a lot of times students like just formula, just easy, quick, back of the envelope type of a formula. You use this formula here. It's P equals 2 pi divided by B. Now, what's the B value? Well, we already talked about how this is the A value. The B value is the number that's right in front of the X. Okay, so it would, in this case, it would be 2 pi divided by 1/2. Okay, Bobby's asking when do the graphs shift. Yeah, we'll talk about that in just after this. So when you divide by half, it's like multiplying by the reciprocal. It's like multiplying by 2, and that's how we got the period of 4 pi. So if you want a formula, yeah, if there's a translation, yeah. So yeah, let's look at a translation. We'll talk about that. Okay, and translations come into play when you're adding or subtracting a constant. Okay, so let's look at that real quick. So say you wanted to graph something like this. Yeah, that's why I said it multiplied. Yeah, exactly. So see, say for example, if you had y equals sine, well, let's just keep it simple for this first example. Let's say you have y equals sine x minus pi over 2 plus 1. So can anybody tell me, like, which way is this graph shifting? Is it shifting left, right, up, down, and by how much? And I just want to say, if you're just joining us here, we're just having a spur of the moment kind of live stream here to talk about ACT math concepts. This is Mario with Mario's Math Tutoring, and I'm just letting people know about this course that I put together fairly recently. It's pretty extensive. It's called the Huge ACT Math Review. We go through 65 concepts. There's 3.5 hours of video, and I go through a lot of examples, teaching, talk about these key concepts that you definitely want to know for the ACT section. So if you're interested, check that out on my YouTube channel or on my website, mariosmathtutoring.com. But back to this problem here. Let's see, Iron Man saying down 1. Okay, let's see. Let me look here real quick at the chat. I want to see what everybody's saying here. Oops. Let's see here. Oh yeah, here we go. Got it. So let's see. Okay, so let's see. Godot says right by pi over 2 and up 1. Okay, let's see who else is saying. Is it shifting left pi over 2 and up 1? Is it negative? So I think right. Iron Man says down 1. Will Cass says, when do you switch between degrees and radians on your calculator? Okay, we'll talk about that in just a second. Okay, all very good questions. But let's take a look here. So basically what we have is we have this. So the number that's grouped with the x, okay, that's shifting the graph in the x direction. But the thing is that it's actually having the opposite effect. So the minus pi over 2 is actually shifting it right pi over 2. If this was plus pi over 2, then it would shift it to the left, right? And then the plus 1, this one has the same effect on the graph. This is affecting the vertical shift. This is shifting it up 1. So basically, to make this long story shorter, right? Okay, you take your basic graph, your sine graph, which looks like this. Okay, and what you want to do, let me just see one thing real quick. I think I'm using an iPhone right now to do this streaming. But you know what it does is sometimes it turns on this the night shift, so it makes it look a little bit darker. So I wanted to make sure that, yeah, you guys can see this clearly. Okay, so basically you take your basic graph. Okay, so here's your basic graph: 2 pi, 1 pi, pi over 2, 3 pi over 2. And these are our key points, right? 0, max, 0, min. Okay, like and so on, right? So, but what's happening is that each one of these points is going right pi over 2 and up 1. So if you take this point, right pi over 2 is one step to the right, because see how our scale's pi over 2? And then it goes up 1. So right pi over 2 up 1, that goes there. This point goes right pi over 2 up 1. This point goes right pi over 2 up 1. This point right pi over 2 up 1. This point right pi over 2 up 1. And so you can see there's our new graph. Okay, so you're with me so far. So that's the way I kind of like to do it. I like to draft the parent function and then shift the points, as a second step. Okay, so what do you think? Any questions about about that. Now notice I switched from degrees to radians, right? So, Will was asking, how do we know when to use degrees or radians? Well, a lot of times, what I usually do is I read the problem kind of quickly and I glance at the multiple choice answers to see, is it giving me answers in radians? Is it giving me the answers in degrees? And that can kind of help to formulate, what kind of form you want to put it in. But remember, how do you switch from degrees to radians and radians to degrees? You want to know this conversion factor, pi over 180 or 180 degrees divided by pi. So that's how you convert. So pi radians is the same as 180 degrees. Okay. So what do you guys think? You guys are hanging in there with me? Are you picking up some pointers? That's the whole goal of this live stream. We want to give you some pointers to help you with the ACT math. What other questions did you guys have? I wrote some down here on the side. There was a question about circles. Let's see. Tina says, what happens when there's a number in front of the x? Okay, good question. Lexi says, one of the topics I see on the ACT is matrices. So if you could do one of those as well, I'd appreciate it. Okay. And Godot says, can you tackle my problem, please? Okay, well, let's kind of see. I want to make sure that I'm kind of giving everybody the ACT asks about tangent, cotangent, secant, or cosecant graphs, or they be mainly about sine and cosine, from what I can tell, from previously released tests, mainly about sine and cosine. But yeah, so basically, okay, Tina was asking about, the number in front of the x. So let's just say, for example, we were to graph this one here. You guys have a lot of interesting questions about the trig function, so let's look at this for just one more minute. Zara's saying about permutations, please. Okay, we can talk a little bit about that. I'll make a note. There's so many different concepts. I mean, you know what they're trying to do, don't you, on the ACT? They're trying to make sure that you have a good understanding of Algebra 1, pre-algebra, Algebra 2, trigonometry, geometry. Those are the main concepts, right? So a little bit of each, the most important points from there. So that's what we're going through now. Here we're talking a little bit about trigonometry and just a little bit about the graphs. There's not a whole lot about this. There might be like one question. Maybe it might just ask you the period, or it might ask you the vertical shift, or just when they give you the equation. So maybe what I'll do right here is I'll show you what are the main concepts again. You mean for the ACT? Yeah, so the ACT math section basically covers pre-algebra, right? Algebra 1, Algebra 2, geometry, trigonometry. That's basically it. Basically goes through those concept areas. So if you know all of those, you're going to be in good shape. But let me show you kind of like a basic layout, I guess you could say, or format for these sine and cosine graphs. So they're basically in this format: y equals a. Will Cass says, I bought the huge ACT review from your website and it helped a lot. I would recommend others buying it as a cheaper alternative to other math courses. In my opinion, covers the same things. Wow, that was, yeah, I appreciate that. I appreciate that. That's really, yeah, I mean, I think basically it does have a lot in it. I put it together over quite a long time, and basically I looked at all the previously, well, I shouldn't say all of them, but a lot of the previously released ACT exams, and I kind of looked at, what are the main concepts, that they're expecting students to know, and I tried to formulate my own types of problems, similar types of problems, and went over all the concepts, kind of reviewed a lot of the different things. So yeah, if you're interested in boosting your score on the ACT math section, definitely check that out. It's the huge ACT math review. But here, okay, so the question before was, what happens if there's a number in front of the x? Well, you see this b value? This b value is what stretches the graph horizontally or compresses it horizontally, right? Okay, Tana says, I also watched that same video. Oh, I think, Tana, you might be thinking of a different one that I released. Will's talking about the one that I just put together recently, the huge ACT math review. It has 65 concepts, 3.5 hours of video. It's not, you can check it out. It's on my YouTube About page, or it's on my website. Okay, but basically, yeah, let's look at an example here. So I'm going to show you like a real challenging one. So say you had y equals -3 sine 1/4 x minus, let's see, what could this be? Let's just say that this was 8 pi plus, well, let's not make it 8 pi. Let's just make this pi over 2, and we'll make this plus 2. Okay, so let's go through this one by one. Tina says, I'll purchase it for my next ACT since I'm procrastinating with the one I'm taking Saturday. Okay, so let's see. So basically the negative, let's go through it one by one. What does the negative do to the graph? The negative does what? Can anybody tell me the negative? We said reflects it, right, over the x-axis. Okay, the 3 does what? It stretches it. It's a vertical stretch, right? Lexi says it flips it. Yeah, the negative flips it. The 1/4, what does the 1/4 do? Well, this is the one that tricks students. The 1/4 actually, it looks like it's less than 1, but the 1/4 is actually going to stretch it horizontally. It's going to multiply the x values by 4. Okay, and remember, you can use that formula, 2 pi divided by b, right? 2 pi divided by 1/4, so the period is actually going to be 8 pi, okay? And then the pi over 2, remember this is the opposite. The one that's grouped with the x has the opposite effect. The minus pi over 2 is going to shift it right pi over 2, and the plus 2 is going to shift it up 2. Okay, so you're with me about that? So this one and this one have the opposite effect. They're grouped with the x. This one, not grouped with the x, not grouped with the x. That has the same effect on the graph. So are you guys with me so far? Do you want to ask me a question? So negative reflects it. 3 is a vertical stretch. 1/4 is actually a horizontal stretch by 4. The pi over 2 is shifting it right pi over 2, because remember this is the opposite effect, and the plus 2 shifts it up 2. And yeah, so that 3, Zahara, is a vertical stretch. Now if it was a 1/3 or a half, then it would be a vertical compression. So it'd be taking these sine and cosine waves and it'd be compressing them or making them so they don't go up quite as high, right? It's a vertical compression. So what do you guys and gals think? I mean, we're at 54 minutes right now. It's kind of a long live stream. I don't want to break the YouTubes, you know. Just kidding. But yeah, I just want to make sure you guys are getting something out of this. Want to make sure that you guys score well on the test on Saturday. Earlier we talked about factoring. If you want to go back to that on the live stream, I'll have this you know, up on my channel so you can see that in a little while. But other questions you guys want to ask about? We've got maybe 5, 6, 7. We'll see how long we're going to be here for, but we'll try to stay here for an hour, and then we'll see about wrapping it up. But what do you guys think? So there was a question about circles, Tana was saying. Lexi is saying about matrices. Oh yeah, and Godot's asking a kind of a specific question about x plus 1 over x squared, which is equal to, Bobby's saying matrices. You know, some of these questions I covered, like I had a couple live streams this week because you know, the school district that I work with, the students I work with here, they're on vacation, so I've had a little bit more time to spend on this. That's why I kind of dug into doing some of these live streams. This is my third live stream. So some of the stuff I covered, the matrices I covered, Lexi. It was either on the last ACT one I did a couple days ago. You might want to check that there. And then Godot, you're asking a specific question. Let me write it down here so everybody can see it. Maybe somebody else can help jump in on that one. And somebody else asked about circles earlier, so I'm trying to see if we can get that in here too. So let me see if I got your question right here. Yeah, Lexi, that video, you can check it out. It's for sale. It's on my YouTube about page. It's the huge ACT math review. Okay, so basically, what was that question again? Let's see. Let me write it down. So it was g of x equals. Okay, and Tina's jumping in and helping with that. Good. Let's see. So g of x equals x minus 1 over x squared, which of the following expressions is equal to g of x minus 1 for all x in its domain? Oh, okay, good question. And so Godot's, Tina's saying, would you need to plug in x minus 1? Yeah, you know, the thing is, that's what I'm kind of thinking. I don't know. I don't have the problem in front of me that you're referring to, so I don't know exactly what you mean. But it sounds like x minus 1 is your input. And so what you would do is you would substitute the x minus 1 in place of x, see, like this. And that's, you know, this is something that I talk about, you know, too, quite a bit about. I talked about this in the last live stream, just about functions. But yeah, whatever's in the parentheses, that becomes your input. That goes in for x on the right side of the equation. You're substituting it in place of x, and you're simplifying. And that's how you would go about that problem. So I hope that helps. I hope that helps. Okay, but let's talk about circles a little bit, because I think somebody asked about that earlier, and I'm trying to do these in order, just kind of first come, first serve, but I'm also trying to make sure it's something that you guys are all interested in. So this is an important equation. If you know this equation, okay, I'm going to build some suspense on this. If you know this equation, it can easily boost your score by 1 point, right? 1 point. So even if you boost it by 1 point, that could make a difference, right? You know, you keep adding an extra point here, an extra point there. Before you know it, you're going from a 25 to a 30, or you know, so on and so forth. So, does anybody know the equation of a circle? Does anybody want to jump in and let us know what the equation of a circle is, and then we'll do a circle example? We know what a circle is, right? It's a set of all points that are equidistant from a given point. That given point is called the center, right? And we usually call that center point h comma k, right? And we know that there's a point on the circle. Yep, okay, Tana says she knows that the radius is squared. Okay, good. And the point on the circle I'm just going to call x comma y, and it's always a fixed distance from that center point. That's distance we call r, the radius. And check this out here. If you guys know the distance formula, okay, what do? You take the difference between the x coordinates. So see how I'm taking x minus h, that's the center point right there, x minus h squared, plus the difference in the y coordinates, y minus k, the quantity squared. And if you take the square root of that, that gives you the distance between those 2 points, which in this case, instead of calling it d for distance, I called it r for radius. But what we're going to do is we're going to square both sides. The square and the square root cancel one another out. And so what we end up getting is what they call the standard form of the equation of a circle. And it looks something like that, right? It looks exactly like that, right? So the idea here is the center of the circle is going to be h comma k, right? And r is the radius. So I'm going to give you an example. So this is an easy one to get right. If you understand this equation, easy extra point on your ACT math section score, right? But I'm going to show you some of the pitfalls so you can kind of avoid those. So can anybody tell us, what's the center of this circle and what's the radius and how would we graph it, right? We'll do all three of those. So what's the center first? Can anybody jump in and tell us what the center of that is? Okay, Tina says it's positive 2, negative 3. Okay, is she right? What do you guys think? Is she right about that? She says the radius is 7. Is she right about that? Will says it's 2, negative 3. Is he right? Bobby says positive 2, negative 3. Is he right? Looks like everybody's coming in. Okay, Zahara is saying negative 2, 3. Okay, Natalie Phillips, yes, she's right. Okay, well, let's see. You guys, here's the key thing. You're absolutely right that you look at these two numbers, and remember, it's the opposite sign. So minus 2, it's actually going to be a positive 2. Opposite of 3 is going to be a negative 3. A lot of students, they don't know that. They make that mistake, but it's really easy. It's the opposite sign. And the radius, remember, this is actually the radius squared. We had to take the square root. So that's actually going to give you a radius of 7. And if you wanted to graph this, I'll just draw a quick sketch for us over here. You guys can see this. It's going to be right 2, down 3. That's your center. And what you would do is from here is you would go up 7. I'm just going to estimate. Down 7, right 7, and left 7 from that center point. And by doing that, that'll allow you to get a pretty good sketch of your circle like that. And you got it. All right, so we're at the 60-minute mark. I just want to ask you guys if there's any other questions. I also want to say, if you haven't, subscribe to the channel so you can be updated, when I go live on some of these videos in the future, or just if you want to find out about, more about math in general for your class or for SAT or ACT. I have a lot of those videos on my YouTube YouTube channel, Mario's Math Tutoring. Like this video if you guys liked it. Give me a thumbs up if you found it helpful. Comment, in the comments. I'd appreciate that. Anything that I can maybe do better, if there's something that, that I could do better. Caesar's saying transitive properties. Okay. Jet saying bravo. Okay, I appreciate that. Yeah, but give me a thumbs up if you thought this was helpful. Definitely leave me some comments if there's something that you want to see in the future or something I could do better. I'm trying to look to improve. This is only my 3rd live stream, and so I'm just trying to refine it as I go here. But maybe we'll just talk briefly about one last question, if anybody has one last question. But before I do that, okay, Tammy's saying hello. Hi, Tammy. What we're doing here is we're talking about ACT math preparation, but I just want to let everybody know one last time, if I can, is just about this course that I have for sale. It's the Huge ACT Math Review. It goes through 65 concepts. It's about 3.5 hours of video. There's teaching that I go through a lot of different concepts, so basically 65 concepts, a lot of example problems, opportunities for you to practice problems on your own, which we then go through together. It's pretty much jam-packed. Will was saying earlier in the chat that he found it really beneficial, and so anybody that is interested in that, there's some free previews, so you can check it out to see if it's something that is of interest to you. You can find that through my YouTube About page, okay, or through my website, mariosmathtutoring.com. And I'm just trying to think if there's anything else. We'll just maybe do one last question, if anybody has one last question. But again, just if you want to give me a thumbs up on this live stream, if you want to subscribe to the channel, that would be great. And other than that, we'll just do one last question, then we're going to wrap it up. So anybody else have any other things they want to talk about for the ACT math coming up this Saturday? What do you guys think? Anything you want to talk about? One last question. We're going to take one last question. Any brave volunteers? What do you guys think? Anything you want to talk about more before we close up this live stream? What do you think? I know some people had some concepts. Okay, somebody says, Caesar's saying the transitive property. Tina's saying something difficult. Bobby's saying ratios. A lot of good questions. I'm just trying to think. I mean, transitive property. Well, I mean, I could show you something kind of related to the Jet saying probability. Jet, you might want to check out the live stream that I did, I think it was 2 days ago. We talked a little bit about probability. That might be helpful to you. There's a live stream that I just did 2 days ago. Okay, well, we'll talk a little bit about the transitive property. See, this problem, the transitive property, sometimes, they talk about this when they're talking about logic. And you guys ever learn this? Like, if P, then Q, that's a conditional statement. Like, if you study your math, then you'll get a good grade. Mario studied his math. What can you conclude? He got a good grade, right? Okay, but then if you add another conditional statement, if Q, then R, if he got a good grade, then he's going to do well on the ACT. So then you could say, if he studies his math, then he'll get a good grade. If he gets a good grade, then he'll do well on the math ACT. So if P, then Q, if Q, then R, you see this like train forming, you could almost say. It's like this connects to this, and then this connects to that, and so on, right? It's like a train, some people say. Okay, P leads to R, right? Okay, so this is the transitive property. If P, then Q, if Q, then R, if P happens, therefore R happens, right? So you're with me so far? So that's the idea. So that's the transitive property. But, in logic, the laws of logic, they call this the law of syllogism, right? So, on the ACT, sometimes they'll ask you, given that this is true, okay, Caesar's saying, will it always be connected with the beginning and last number? The thing is, Caesar, that's a good question, because they could actually give you this statement first and this second statement, but it would be up to you to realize that you would have to, set them up in such a way that, P causes Q, Q then causes R, therefore P causes R. So they could definitely switch these on you, right, to try to confuse you, or just to try and see that you understand the concept of the transitive property or this law of syllogism. So they might ask you, A, B, C, D, E, which of these is true? Is, if Mario studies his math, does he do well on the ACT? Well, we know if he studies his math, he gets a good grade. We know if he gets a good grade, he's probably going to do good on the ACT. But, I'm just making this up as a silly example, but we know that this is the law of syllogism, that this first is going to cause the third through that chain of events. So I hope that clears up the transitive property, the law of syllogism. These are called the laws of logic. If you want to see some more examples, you can go to my website. It's just called the laws of logic. You can check that out. It's the law of detachment, law of syllogism. I have a whole video on this if you want to review this more. But I think, in conclusion, I just want to thank everybody for joining me. And again, I want to just mention this huge ACT math review. Check out the 3 free previews on there. See if it's something that you think is going to be beneficial to you. Will was chiming in earlier that he got a lot of benefit out of it. He actually purchased the course, and he said that it really helped him. So check it out. See if it's something that's going to be a benefit to you. And I just want to say thanks again for joining me. And I want to wish everyone the best on the ACT on Saturday. And I look forward to helping you guys out with your math in the future. I'll talk to you guys all soon. Bye.